Our next topic for this particular chapter is work. And first we need to define what is work. We're going to define work as a transfer of energy, generally into or out of a system. The other thing that work can be is a conversion of energy from one type to another. Our symbol for work is a W, and in notation form, work equals a change in energy. When we do work, we apply a force in the direction of travel. That's critical. Over a given distance. So an equation for that is work equals force parallel times d. And the work has to be done by part of the force that's parallel to the direction of motion. So another way of writing this would be force times the cosine of the angle times the distance. So we've learned about energy already. Work is simply a transfer of energy. So let's take a look at some work problems. I have a 20 kilogram suitcase. I lift it 3 meters. Using a conveyor belt, how much work is done on the suitcase? So work is a change in energy. What kind of energy is changing? Well, the gravitational potential energy is changing. If I say that the suitcase is on the ground and it has 0 gravitational potential energy, then the gravitational potential energy it possesses at 3 meters is going to be the amount of work that had to be done on the suitcase. So I have 20 kilograms times 9.81 newtons per kilogram times 3 meters. And so my work is 589 joules. And that is work done on the suitcase because the suitcase gains energy. If we look at the next one, we've got a passenger dragging her suitcase with 100 newtons of force, and she's applying that force 60 degrees to the horizontal, and she drags her suitcase for 200 meters. We want to know how much work she does. So we have a force, we have a distance, so we're going to use the work equation that involves those two quantities. So it's force parallel times distance. So we have 100 newtons of force times the cosine of 60 degrees times 200 meters. So we put all that into our calculator and make sure we're in degrees, not radians, and we get 10,000 joules. All right, let's take a look at this one. Joe's pushing his car up a hill. He uses a force of 300 newtons. He's pushing in angle of 30 degrees, but the car won't move. How much work does he do? Well, let's set it up. We have work equals force parallel times distance. Well, we know the force, 300 newtons. We know the angle, it's 30 degrees, but it won't move. What's our distance? Well, if it doesn't move, then our distance is 0. If you apply force and nothing happens and nothing moves, guess what? You do no work. That can be somewhat discouraging when you're pushing on something and you're expending an awful lot of energy, it feels like, but nothing happens. So according to classical mechanics, you're doing no work. If you take a look at number 4, we've got a 1,000 kilogram car. It's rolling to a stop, so we have movement that's changing. Distance we're given is 10 meters. Find the amount of work done by friction. We've got a friction coefficient. All right, we've got all kinds of stuff going on here. Okay, so work is my friction force times distance. Friction force. That's friction coefficient times normal force. Well, it doesn't say anything about an angle, so I'm going to assume that my gravitational force is equal to my normal force. So that means I need to find friction force. Well, I've got 1,000 kilograms times 9.81 newtons per kilogram. So there's Fg, and Fn, and now mu, 0.2. So my friction force is 1962 newtons. So the work is going to be that, 1962 newtons, we'll get to sig figs later, 10 meters, 19,620 joules. Okay, look back, I have 3 sig figs, 4 sig figs, 2 sig figs, so my work in this case is 20,000 joules. All right, let's look at number 5. We've got a couple of situations here. We're supposed to tell whether the everyday or scientific meaning of work is intended. So Jill had a lot of homework last night. Is that scientific work or everyday? Hopefully you said everyday. Judy works 20 hours a week. Is that every day? Yes. Could it be scientific? Maybe. It depends what Judy is doing when she does her 20 hours of work. Maybe she's pushing things. Maybe she's lifting things. Maybe she's dragging things. So unclear. It could be either one. Joy did a lot of work. She had to carry a box of books up 3 flights of stairs. Is that every day? Maybe. Is it scientific? Definitely. Ms. Moffat and Ms. Howell give us too much work. Every day or scientific? Well, it's not scientific, so it must be every day. So that's taken us through work, definition, and some practice problems.